All right. If I could get somebody in the audience to kindly put in the chat that you can see my screen, that would be awesome. You should see a Blazor WebAssembly slide. Okay, perfect. Thank you very much. Cool. All right, we'll get started here in just a few seconds. I thank all of you for making an effort to come out today to participate here in our webinar. It should be a lot of fun, and looking forward to sharing with you a whole variety of different things regarding Blazor. We'll get started here in just a couple seconds. And by the way, while we're waiting to get started here, if you have any questions on anything that we talk about, put the questions into the question box, and then I'll be doing the questions at the end, okay? All right, looks like we are at our 11 a.m. Pacific time start time here, so let's go ahead and get our webinar kicked off here. I want to welcome everybody to our webinar on Blazor WebAssembly, C# programming in the web browser. My name is Eric. I do a lot of teaching for Wintellect, teach a lot of classes, create a lot of videos. I also write blog posts and other things like that, and try to do my best to help people learn more about software development and about technologies that I'm excited about. And one of the ones that I'm super excited about here is Blazor WebAssembly, which is what we're going to be talking about here for the next hour or so. Before we actually get into the content, just a few things here about Wintellect. Wintellect provides 3 core services: consulting, instructor-led and on-demand training, kind of experiencing part of that here with the webinar, and then CSP and managed services for managing Azure environments. Wintellect is the IAMCP 2018 winner worldwide. They're a gold level Microsoft partner, premier consultant with Xamarin, as well as a GitHub verified partner. So if you're looking for a company that has the partnerships and the resources to help you work in the cloud, particularly with Azure, Wintellect is the company for you. In addition to all of the things related to the organization, the people who work with Wintellect also contribute greatly back into the knowledge space for software development. Over 30 books have been authored. They literally write the book in many cases on some big topics within the Microsoft stack in particular. We have some special offers here: a free 4-hour advisory session on Azure, app dev, DevOps, data, artificial intelligence, and mobile development for being a part of the webinar. Free disaster recovery setup for new Azure managed service customers, as well as up to 3 months of complimentary Azure managed services for new customers as well. If you have any interest in this, check out the website here, info.atmosera.com/special offers. Wintellect several months ago was actually purchased by Atmosera, and so Atmosera is big in the cloud space, and you definitely want to check out their services. Okay, let's get started here talking about Blazor and WebAssembly and all that good stuff. I'm going to go through a couple of slides here pretty quickly, and then after we go over the slides, I'm going to do a number of demonstrations. I'm not going to make the assumption that anybody here has any WebAssembly or even client-side web development experience. I'm going to assume that everybody is, has some basic, maybe server-side programming, and I want to kind of walk you through the evolution to where we get to where we are with Blazor WebAssembly. And then after we do that, we're going to take a look at building a small Blazor WebAssembly application from beginning to end to kind of give you an idea of what development with Blazor is really all about. So the first thing you have to know is that WebAssembly itself is actually an official standard. Unlike past technologies, things like Flash or Java Applets or Silverlight, which were proprietary technologies trying to set things up so that you could run binary code in the browser, WebAssembly is a standards-based technology. It's supported in all the major web browsers on all the major platforms, and it basically allows you to write, in our case, a C# program and actually have it run directly in the web browser. So instead of having to write JavaScript code, you can write C# code or any other language that can compile out to WebAssembly, which there are quite a few now. It does not completely replace JavaScript. In the case of working with Blazor, you'll learn that there is some JavaScript code that Microsoft provides as part of the framework for actually performing the DOM updates and stuff like that. But the Blazor or the WebAssembly code itself actually achieves near native performance. And ultimately, you can code it with any language that compiles out to the WebAssembly binary format. In our case, we're going to be using the .NET framework to do that. So what is Blazor? Well, Blazor itself is actually more than just WebAssembly. Blazor is actually a single page application framework. It actually comes in two flavors, Blazor Server and Blazor WebAssembly. And there's going to be a third one, I think, coming up with Blazor Desktop, but we'll see what happens next year with .NET 6. But there's going to be, there's currently two hosting models, Server and WebAssembly. While the focus of today's webinar is on Blazor WebAssembly, there are times when Blazor Server makes more sense for people to use. And the cool thing is a lot of the key ideas and concepts that you use in the WebAssembly form of it equally apply to the server part. And I'll talk a little bit more about that later. The way the server part basically works is it uses WebSockets to do the UI rendering on the server, but then send data back and forth to the client without having to require the page reload. In the case of WebAssembly, the actual UI updates themselves are actually being performed directly in the browser using the WebAssembly code. Now, probably the most important part of working with Blazor isn't really all the fancy WebSockets or WebAssembly or anything else. It's working with Razer components. For those of you who are coming from that server-side MVC type of programming background for building web applications, the big hard new thing that you'll have to learn is how to think in terms of components. The APIs are simple enough, but there's a lot of ideas and concepts that go into the right way to build component trees. For those of you who are coming at Blazor from a React or Angular or Vue type of background, you're actually going to find it to be a very natural shift from those JavaScript libraries and frameworks over to working with Razer components. In fact, several years ago, when I first heard about Blazor and built my first little Blazor application, I actually loaded up a React web application that I built because I teach a lot of React. I loaded up a React web application that I built, and I created a new Blazor project, and I basically took the component tree that I had from React and re-implemented it using Razer components. All the same ideas and concepts and things like that were all present. And so I was able to kind of port that thing over very, very easily, like over the course of a morning. And so the reason why I mentioned that is if you're coming at this with knowledge in these JavaScript frameworks that are component-based, that will really help you get into Blazor. Okay, now, both Blazor models are useful. In fact, a lot of times I'll have a customer call me up and say, hey, Eric, we want a Blazor WebAssembly class. And I'll start asking them about how they're going to use the application, what's the environment in which it's going to run. And before we know it, by the end of the conversation, I'm recommending not Blazor WebAssembly, but Blazor Server. So even though we're excited about WebAssembly, even though WebAssembly is the focus of this webinar, please understand there are times when the Blazor Server is going to make more sense. And I'll talk more about that a little bit later. Now, another cool thing to keep in mind when putting these applications together is the Razer client library. It's a great way to be able to put your components in a library that can then be equally reused with any Blazor application, server or client side, okay? So the main difference between server versus WebAssembly when it comes to building your components is if you have to have any client-side JavaScript code, how the WebAssembly version and the server version components can interact with JavaScript is slightly different because of where the processing is done. We're not really going to talk about that here in today's webinar, but while you can create components in these libraries that can be reused both across server and the WebAssembly hosting models, there can be a couple of issues as it relates to JavaScript, which hopefully is being kept to a minimum, right? That's the whole reason we're using Blazor to begin with. All right, so how does Blazor WebAssembly actually work? To run Blazor in the browser, basically a scaled down version of .NET is downloaded into the browser and executed as WebAssembly. And then the DLLs for your application are downloaded into the browser to then run your application. Now, a lot of people will notice the first time they go to run a Blazor WebAssembly application that it can be a little bit slow to start up, especially on the initial load. And that's because if you don't have the .NET stuff downloaded into the browser, it has to be downloaded that first time. But Microsoft has been working extremely hard to make that download as fast as possible, making the actual amount of stuff being downloaded as small as possible. And then also trying to work on technologies for pre-rendering and stuff like that to help improve that performance, okay? And we'll actually take a little bit of a look at the output from all of that when we get to our demonstrations here in a couple of minutes. All right, so let's get into our demo now. And what I want to do is I want to walk you through a very, very quick evolution of an MVC application and show you kind of what has changed over time so you understand how WebAssembly is fitting into this. So what I'm going to do is fire up Visual Studio here. And the first thing I'm going to quickly create is I'm going to quickly create an MVC application. Now, we're not building an MVC app or anything like that. I just want to create one, run it for you, and highlight something for you here quickly. So we're going to say new project. I'm going to create a regular ASP.NET core web app right here. And I'm going to put this into my webinar folder right there. And we're just going to say server side web app. And we'll go ahead and click next. We'll leave it for .NET 5. And we'll create this real quick. So while this is creating, for people who have done server-side web development, this is where you would build your web apps, but basically write lots of C# code. JavaScript could be optional, but every time the user would interact with the web page, it would cause the actual web page itself to reload. So let me click on this here real quick. We'll fire this up. Okay, so over here, I'm going to open up my developer tools. We're going to go to the network tab. All right, so if I come into here and I decide I want to click on the privacy page right here, I want you to watch what happens over here. I'm going to click on privacy and you're going to see it literally downloaded the privacy page from the server. When you click on this, it's really fast. You don't really see the flash on the screen too much, but it's literally going back to the server, building a new web page and loading it up. And this is how people built web applications since the beginning of web applications. But the problem is it doesn't give the user that great of an experience. So about a decade or so ago, a new way of building web applications started to emerge that became very popular. And that was, instead of rendering pages on the server, we should do our rendering on the client. The problem though is in order to render pages on the client, you have to have some type of language that runs on the client. Well, in the case of a web browser, that's going to be JavaScript. So if we come in here and search in our templates, you'll see ASP.NET Core with React. So go ahead and click next. And this is going to be client-side web app. So for about the last decade or so in web development, when people have been going through and building their web applications, they've been using these JavaScript frameworks and libraries like React and Angular and Vue. And so you do some server-side coding for like your REST API, but then all the clients, all the UI logic is all done on the client side with JavaScript. So I'm going to go ahead and first build this real quick. It's going to have to install a few NPM packages. We'll give it a second to do that. Well, the problem is a lot of C# developers didn't want to jump into JavaScript. Now, I personally love JavaScript, but a lot of developers don't. And the idea of building massive applications with all of this JavaScript code, instead of using something like C#, was very discouraging and frustrating for a lot of programmers. I can tell you when I was traveling around teaching things like Angularjs, that's when people were first making the big jump. Backbone, Angularjs, stuff like that. All of these server-side web developers were very, very discouraged that they now had to write all this code in JavaScript. But why? Because we had to make the UI changes on the client side to give a better user experience, and JavaScript was our only language of choice. Sure, there had been other proprietary technologies like Silverlight and Flash and stuff, but those just didn't really work very well, and eventually browsers would stop supporting them, so on and so forth. So what we're going to do now is we're going to run this one, and this is powered by a C# backend with a client-side React with JavaScript. So now when we load this up, I'm going to come over here to more tools and go to developer tools. Give this a second real quick. That's if it loads. Hey, look at that. Looks like it's going to come to light for us. Okay, so here's this React application. Now I'm going to come over here and I'm going to clear the network. When I click on counter, I want you to watch what doesn't happen. There's no network traffic here, okay? And I have the filter set to all. There's no network traffic. I'm clicking the increment button. We're not reloading anything from the server. We're not even talking to the server. So if this had been written in that previous server-side technology, you would have seen page reloads every time I click the button. But because we're doing this in React with JavaScript, you can see I'm not talking to the server. We're actually doing all the UI updates right here in the web browser itself. So from a user experience perspective, this is a good improvement, right? We're not doing those constant page reloads. From a developer perspective, though, you have to write all the code in JavaScript. So let's get into Blazor. How is Blazor going to allow us to have this single page application experience, no page reloads, but allow us to write that code in C#? Well, the first Blazor hosting model that became production ready was Blazor Server. So we're going to come into here, we'll say new project. I'm going to create a new Blazor Server app, and we'll call this Blazor Server app. There we go. .NET. So how is the Blazor Server app going to work? It's going to give us that single page application experience, but we're writing all of our code in C#. So if we fire this up, perfect. Okay, so now we come over here and open up our developer tools and go over to network. So if I reload the page, you see a bunch of stuff gets downloaded here on the initial page. Now what I'm going to do is, you see this right here, this is a WebSocket. Okay, I'm going to click on the WebSocket. I'm going to click on messages. You see these messages over here? Now watch what's going to happen. I'm going to click on counter. When I click on counter, you'll see there's no new network requests, but you will see where data was passed over the WebSocket. Now watch over here as I click on the click me button. You see how there's new messages going through? Just take a look at that. So where is the code actually executing to generate the new UI? The code executing to generate the new UI is being executed on the server. But instead of doing a page reload to update the UI, the updated UI is now coming over WebSockets into the browser, and then there's some Blazor JavaScript code ultimately that's going to take that information and then update the actual DOM tree with it. So with Blazor Server, I get the good user experience in the sense that it's a single page application, but the developer is able to write their code in C#. What's the downside to this approach? You have to maintain the WebSocket connection, which of course takes up server resources. Also, all your UI updates are being performed on the server. So with the React application, everything was client side. That reduced the load on your server. But now with Blazor Server, you're getting that React user experience, but you're still putting a tremendous load or a more of a load on your server to generate the new UI, to manage the WebSocket connection and stuff like that. Now, when is a Blazor Server app going to be possibly a good choice over a Blazor WebAssembly? If you are in an enterprise type of environment where you are relying upon Windows authentication, Blazor WebAssembly is not really going to work that well for you. When you work with Blazor Server, because the code is executing on the server, you can leverage Windows authentication just like you were able to leverage it with the old school server-side MVC applications. So whenever I have a customer come to me and say, hey, we want to learn about Blazor WebAssembly, and I know they work for the government or some type of internal application for a large organization, what have you, I'll ask them, are you planning on using Windows authentication? And if they are, then Blazor Server is going to be the better way to go, because it allows you to leverage some of those older technologies that were basically kind of built into the code running actually on the server. So even though you get the great user experience here, everything is still itself running on the server. Now, let's take a look at Blazor WebAssembly, the reason we're here. So we're going to get to the final step here in our evolution. So now I'm going to come into here and create my Blazor WebAssembly project. And let's talk a little bit about this. Okay, so now we're going to come into here and we're going to go ahead and fire this up. See the loading? It's downloading stuff. All right, there we go. So now if I come into here and I go to my developer tools. Okay, so I'm going to clear this and I'm going to come over here and click on counter. There's no WebSocket here. I'm not paying attention to any WebSocket, nothing. I'm just literally going to come over here and click on counter. I click on counter and now I'm going to click on click me. So now we are achieving with Blazor and C# code what we did with React. I can update the UI. The code is running completely in the browser, okay? And there's no network traffic going back to update things. Now, of course, a real application will need data. And so just like in a React application, you would see calls back to a REST API or GraphQL endpoint, you would see the same thing here ultimately if we were calling back to receive data and stuff like that. But in terms of just literally updating the UI itself, we don't have to go back to the server. So remember, we started off in the beginning with a server rendered app. Then we did UI updates with JavaScript. Then we were able to give the user experience of those client-side updates, but still letting the server do the processing. And now we're actually running our C# code here in the browser. Now the question is, what did it look like on that first page load? So for example, we've loaded this up. I'm going to click this right here, click refresh. All right. And you'll see that time it was faster. And you'll see not that much was downloaded. But that's because we've already downloaded all the DLLs on the initial load. I want to show you what it looks like to download all of those initial DLLs. So what I'm going to do is I'm going to come over to here, and we're going to go to settings, and we're going to clear our history. Okay. We've also got our, on the networking, disable cache. I find in order to actually see these things get downloaded again, you have to both clear the history, disable the cache, everything. So now that I've done that, let's go ahead and reload this and let's see what happens. There we go, my friends. All right, so these are all the DLLs that got downloaded. See, it basically downloads this scaled down version of .NET. Now, most of these are actually relatively small, but if we come in here and actually sort this by size, let me scroll to the top, you'll see a couple of these are actually quite large, all right, over a megabyte in size. So one of the things that people will complain about when they work with Blazor WebAssembly is there's a lot of stuff to be downloaded, and that initial loading is a little bit slow. And that is definitely it's a credible criticism of the Blazor WebAssembly a little bit. Now let's take a look here at what this actually looked like when it loaded up. So it was 22.8 megabytes worth of resources. 9.2 megabytes were actually transferred. Now the reason why only 9.2 were transferred was one of the things that will happen with a Blazor app is all of these dependencies actually get compressed down to gzip and then another compression standard called Brotli, if I'm pronouncing that right. Brotli actually gets you a little bit better compression, and if you have your web server and stuff set up for that appropriately, it'll serve up those slightly smaller files instead of the gzipped version. But on that initial load, quite a bit was transferred. But here's the thing. If I reload this again, now a whole lot less was transferred. So if you already have this downloaded and you go back to the website and load it again and stuff like that, it will load relatively fast, very fast. It's just that initial time that you go to view the site, it can be a little bit slow in terms of trying to pull down all of that content and load it up. Now, of course, if you get into things like HTTP2 and you can send back multiple things in a request and things like that, a big part of the initial slowness actually is going to be related to latency. So if you're putting your static assets, which is what all of these things are, out onto a CDN or something like that, you can achieve better performance on that initial download. But then after that, you can see it's actually relatively small. Now, of course, the more stuff you add to your application, the bigger it'll get. Like recently, I've been working on an app that uses a data grid and some other third-party components, and the download for that DLL is a little bit large, so that can make the application a little bit slower to load initially. But once it's downloaded and you're in there and using it, then the performance is really good. Now, what I want to do is I want to show you something kind of interesting here. I'm going to right click on this and I'm going to do publish. And we're going to take a look at the actual published output of this WebAssembly application. We're going to publish it out to a folder. And let me browse for the folder that I want here. Give me a moment. And I want to go to here. And then I want to go to here, here, and here. Okay, perfect. So we'll go ahead and say finish. And I want to have this delete all existing files. Great. Okay, so what we're going to do is we're going to go ahead and publish this thing out to this folder. And I want you to take a look at what the actual published output is. So we'll give it a second to do that. After we take a look at this publishing thing, we're going to run it real quick with an Nginx web server. And then after that, we're going to take a look at how you would debug some of this code. It's kind of cool. Give it a second here to publish here. And while that publishes, let me go over to here. After we take a look at the debugging, then we're going to actually create a Blazor WebAssembly application. And we'll take a look at things like the Razer client library and forms and doing some validation and talking to a REST API, stuff like that. All right, cool. So it's all outputted here. So we'll come into here and I'm going to go into HTML, www-root. Okay, so this is the actual output. This is what was created. I want you to notice something here. Everything is literally just a static asset, right? So here's the favicon, then there's the gzip version, the Brotli. So they're already all pre-compressed. So you don't have to do the on-the-fly compression of the web server. It gives everything to you already pre-compressed. If you go into framework here, these are all the actual DLLs that it produces for you, okay? So if we come in here and sort on size, right? So there's, well, let's sort by name actually, and I'll scroll down to, actually, let's do this one right here. Okay, so take a look at this. This is the .NET WebAssembly file that actually is the WebAssembly piece of this. And you can see normally it's 2.7 megabytes in size. But if you come down to the gzip version, it's down to a little over a megabyte. And then take another, 150K off of that for the Brotli. So you can see these pre-compressed versions of the output, can definitely be very helpful for making things download faster. Now, what I want to do here real quick is I'm just going to come into here and say start Nginx, and I want to just really make a quick point here about something. So we've got a web server started there, and I think I've got it on port 8080. Okay, so this is our Blazor app here running on Nginx. I want you to notice something. There's no Visual Studio, there's no IIS, there's no server-side anything. It's literally just a bunch of static assets that were downloaded from an Nginx web server that are loaded up in the web browser, and we're running our .NET code. So one of the things that I find sometimes happens when people get into Blazor WebAssembly is even though they know we're running WebAssembly and C# and all that in the browser, it's like they keep forgetting that. And they keep thinking there's this server-side piece to it, but there isn't. This is just like running React in the browser. All the code is here, all the code is executing in the browser. There is no server-side part to it, okay? So when you do WebAssembly, you can have a .NET backend, which we'll actually have for our demonstration, but your backend could be anything. It could be Python, it could be PHP, it could be Java, it could be anything you want it to be. You literally just have a client-side application that's using C#, okay? So anyways, it's pretty neat how this actually works. And like I said, all the techniques that you would do to make static assets get delivered to a client as quickly as possible, all of those things can be applied here to make the app load as quickly as possible. Now, one last thing I'll say about the performance aspect of it, and then we'll talk about the debugging, is that I know for some people that even slightest of a delay is going to be a a non-starter for them. But I will mention this. The internet gets faster and faster and faster all the time. The tools and techniques and stuff that we use to deliver content are faster and faster and faster all the time. If you give developers the choice of working in a language like a C# or a Python or a Java or a Golang or whatever, or doing JavaScript, as much as I love JavaScript, developers would love to use those technologies. WebAssembly, even if this slight delay is a little bit too much for you, WebAssembly is going to be the thing that kills off JavaScript. It won't kill it off completely, but if you have a choice of writing thousands and thousands of lines of code in C# or writing thousands and thousands of lines of code in JavaScript, I know what most developers would probably choose. And so as you're getting into this WebAssembly stuff, keep in mind, we're at the very, very beginning. This isn't like the midpoint or the end. This is the very beginning. And this is pretty amazing for what you can do here at the very beginning. All right, so let's take a look at how you would debug this, because the first question I would have is, well, how can I debug WebAssembly in my web browser? Well, let's take a look. The first approach we're going to take a look at here is I'm going to show you three actually. I'm going to show you how to debug it in Visual Studio, Visual Studio Code, as well as directly in the web browser itself. All three options are available to you. So let's start with the easy one, right? We'll go for the low-hanging fruit. I'm going to open up under Pages here, Counter. And then here what I've got is I've got my counter here that increments, right? Well, I want to set a breakpoint and hit that breakpoint every time I click the button. No problem. I'll set a breakpoint right here in Visual Studio. So remember, this code is running in the web browser. We'll fire it up. We'll click it. So I'll come over here to my counter, click me, boom. I hit the breakpoint right there in Visual Studio. Can't get any easier than that. So I'm now debugging my client-side C# code directly here in Visual Studio. Okay, let's take a look at another way of doing this. Even though I'm demoing Visual Studio to you, actually I write most of my Blazor code with Visual Studio Code. So let's go ahead and let's close this up for the moment. And then I'm going to come over to here and let me go into there. And I'm going to go into our Blazor WebAssembly app. And let's see, I'm going to open this up with VS Code. Now, in order to do the debugging here and development with VS Code, you're going to need two extensions installed. You'll see I've got the C# extension. That's the OmniSharp one that most people are familiar with. But there's also this one right here, which is the Blazor WASM debugging extension. You'll need that to also be able to debug here in Visual Studio Code. So now what I'm going to do is we'll come over here to our project and we'll go ahead and create, and we'll do, now I'm going to warn you ahead of time. Sometimes setting this up works great the first time, sometimes it doesn't. So come into here and let's see. Nope, hold on, let's go ahead. Let me do this real fast. All right, I'm gonna do one thing here. I'm gonna close that real quick. Let me come over here and delete this. All right, let's try this again one more time. Actually, let me do a regular .NET Core one first. Ah, I can't believe this is not going to work. Hold on one second. Let me see. That time it completely blew up. Let me try one more time. And I'm going to take this off of SSL because oh, now it's actually dying on me. That's not good. All right, hold on one second. Let me do one more thing. I'm going to grab this version here. All right, let's try that one more time. Ah, there we go. Okay, so I have an issue with the SSL certificate with .NET on this particular machine, so that's why I'm loading it up without SSL. Okay, so here's our Blazor application loaded up. I'm going to come back over to here, and you'll see I've got a breakpoint set on current count. So I'm going to come over here and click on counter and click on click me, and now you can see it's picking up my current count right here, and I can do my debugging here directly inside of VS Code. Now, what about doing it directly inside of the web browser itself? What does that look like? So let's go ahead and actually, hold on, let me start that back up again real quick. So you can do regular Visual Studio VS Code. Now this is going to be debugging it here directly in the browser. So to do this, what I'm going to do is I'm going to hit Shift Alt D. So Shift Alt D, and that's going to fire up basically like a debugging session debugging Chrome. So what happened was when Visual Studio Code launched the application, it actually launched the browser in a special debug mode. And so now I can debug my WebAssembly code through this special window here. Now, if I come under File, you will see that under Pages, Counter, this is my actual C# code literally in Chrome. So I've got a breakpoint that I set here on current count. So now if I come over here and I click on counter and then click on click me, it literally hits the breakpoint here directly in the browser itself. So with our Blazor WebAssembly, we can debug in regular Visual Studio Code, as well as directly in the web browser itself. So let's go ahead and walk through a quick little demonstration here to build a simple application using Blazor WebAssembly and kind of explore some of the basics of structuring a project, how to work with components, so on and so forth. So I'm going to go ahead and open up Visual Studio here. Come up over here under File, New Project. Now we're going to create a Blazor WebAssembly app here, so we'll double click that. And we're going to call this Color Tool App. And I'm going to create this in our folder here. There we go. We'll go ahead and click Next. Now, as we saw earlier with a WebAssembly application, you can simply just create it, run it on the client. There's no server part to it. But commonly in web apps, you do need an actual web server to serve up the static content of the WebAssembly app.
but you also need like a backend REST API or something to get data. Now with Blazor WebAssembly, it doesn't matter what your backend is coded in, but here in Visual Studio, it'll give us the option of basically hosting it within an ASP.NET website, which we can then use for the REST API. But keep in mind, the WebAssembly itself, when it actually executes at runtime, it is running completely independent of the server. It's running just on the client itself, the browser. So I'll go ahead and check this, and we'll host it in ASP.NET so we can use that as our web server and our REST API. Then I'll click Create. All right, very good. So now we've got our application created here. You'll see we have 3 projects: the client, the server, and then shared. Shared is where you can put classes and stuff that can be shared between both the client and the server project. The client is the Blazor WebAssembly. The server is just an ASP.NET Core MVC application. The first thing we're going to do is add a class here under shared. Say new class. And we're going to call this class color. This is just going to be a model that we're going to be able to use both on the client side and the server side. And we're simply going to come into here and just paste that in. There's our color model. The next step we're going to do is go ahead and implement the REST API piece so that we'll have some data that we can call a little bit later on. So underneath controllers here, I'm going to right click and say add class. And then we're going to come into here, we're going to call this colors controller. And I'm going to come into here and just simply paste that in. So there's our colors controller. Just some basic methods for getting all the colors, adding a color, as well as deleting a color. So now that we've got the REST API implemented, let's go ahead and turn our attention now back over to the WebAssembly, which is why we're all here today. So what I'm going to do is come underneath pages here. We're going to create a new page. And we're going to say Razer component, and we're going to call this color tool. Now this is going to create basically a H3 element, just a little header, and a little code block that we don't have any code for yet. But what I do need to do is connect this into the routing system. So the way that you do that with Blazor is the page directive, and then we'll say color tool like this. So what that means is whenever our URL path is /color tool, this page will load up. Now we need to be able to call this page from the menu. So I'll go over here under shared to nav menu, and you'll see down here there's a nav menu link list. And I'm simply going to add a new list item here with a link to color tool. There we go. So there's color tool. So now if we go ahead and run this thing, okay, great. Now that it's all loaded up, we can come over to here and take a look at color tool in the menu. And you can see there's our /color tool there in the URL. And there's our color tool page that's being displayed. If you actually right click on this and click on inspect, and let's actually go in and inspect that element, you can see there's our H3 from that component that we just placed on the page itself. So now that we've got our page created, now we want to create some components to add to the page. Now we could create these components directly in the client application, but one of the things I wanted to highlight here to you was the value of the Razer client library. As we talked about earlier, with Blazor, you can do both a WebAssembly hosting model or a server hosting model. Well, the cool thing is if you put your components into a component library independent of the Blazor application itself, you can actually reuse those components for the most part in both a WebAssembly or a server application. So if you're unsure which hosting model you want to use, you can always change your mind later if you put these components in their own separate project. So to do that, we're going to come under solution here. We'll say add new project. We're We're going to do the Razer class library. Now the name of this is going to be Color Tool App Components. So we'll just paste that in like that. Boom. Okay, so now what we want to do is set up some project references. Color Tool App Components will need to know about the shared project. So we'll come into here and say Add Project Reference. And we're going to click on Shared. And then we'll come under the client here, and we're going to add a reference to the components project so that it can reference those components. Now, in order to make it easier to reference the components from the components project, we are going to go over here under the underscore imports in the client. And basically any namespaces that are registered here will be automatically available to us when creating our component templates here inside of the client application. Okay, so what we want to do now is go ahead and create that first component in Color Tool App Components. I'm going to right click and say Add New Item. I'm going to grab a new component here. And so we'll come into here and we'll call this toolheader.razor. There we go. And for our code here, we'll just pop this in like that. There we go. So now we've got a little header up here. We've got some header text. This is a variable within our Razer syntax here. That variable is going to be a parameter that's populated by whatever calls the tool header component. So let's go ahead and call tool header. And we're going to do that here over in our color tool page. So we're going to replace this header with this one right here. Now what you'll notice is that this header text that I'm passing in here is what's populating the parameter here, which is populating the @header text right here. So we'll go ahead and save all that and let's run it. And this time our color tool should have a space in it. So now we'll come over here and click on Color Tool, and there you go. There's our space. So let's go ahead and close that. Now what we want to do is go ahead and set up a list of colors. To do that, we'll need a component, of course, but we also need to pull in the actual color data. The way that we're going to pull in the actual color data is by building a service that can call our REST API endpoint. So what I'm going to do here is underneath our client project, I'm going to create a new folder called services. And then what we're going to do is underneath services, we're going to create a new file here called colors data. Class is fine. And we'll say colors data. Great. And let me close that, drag that up to here. Okay, perfect. So all this service is basically going to do is, using the HTTP client, reach out to the REST API that we already coded up and basically retrieve back our colors. So it can get all the colors, add a color, remove a color, so on and so forth. Now, in order for this service to be usable, we actually need to register it with the Dependency Injector. So in a Blazor WebAssembly program, that Dependency Injector is going to be under Program CS here. So I'm going to add a using statement here to pull in our namespace for the service itself. And then to actually register the service, we're simply going to do it like that. So now our service is actually registered. Now, in order to display the color list, we actually have to have a color list component. So we're going to come back over here underneath components. We'll say add new item component. And then we'll come into here and we're going to call this color list. And then we'll go ahead and put the code in that file. There we go. So there's our list of colors. And so now we need to call this component passing in the data from the REST API. So to do that, we're going to actually go back to where all this connects together, which is actually going to be in our color tool Razer file here. And let me copy this real quick, and we'll paste this in here. I'm going to replace the whole file. There's our tool header. But you can also see here now I'm injecting my colors data. And then I'm also coming into here and creating a little variable for my list, and then populating that variable by calling the service. That variable is then passed into color list. And then if you come into color list here, you can see I receive the parameter, iterate over the data, and then display it. So for those of you with experience with Razer syntax, you should feel pretty at home working with Blazor in general. It's just a matter of learning to think of things in terms of components. So let's go ahead and run this again. So now we'll click on Color Tool, and there you go. There's our list of colors. Now the next step in our process here is we want to be able to collect color data off of a form, as well as have some basic form validation and stuff like that. So what we're going to do is we're going to create a form to collect a new color name and a new color hex code. To show you the flexibility of this, as well as to relate it to existing .NET technologies, you can actually use the whole data annotations component model mechanism for doing validation, not only the built-in ones, but also custom validators as well. So let's go ahead here real quick and let's create a custom validator for our hex code to make sure it's a 6-character hexadecimal value. So I'm going to come into my components here, and I'm going to say right click, add new class, and we're going to name this class hex code attribute. If you remember, the actual validators are applied as attributes to the model. So we'll click add. So now what I want to do is go ahead and put my code in here for this. There you go. There's my attribute. It's basically just going to check to make sure that it matches the regular expression based upon whatever desired length. In our case, it's going to be 6 characters. So now that I've got the attribute in place, now I need to create the form. So I'll go ahead and create another Razer component here, and we'll call this color form. So take a quick look here at color form. We're using this edit form attribute here, or edit form component in order to set up our form. Now, one thing we actually do need to do before this is going to work is we need to come over to our imports. When you create a Razer class library, it does not include the import for working with the Razer component forms. So if I put that in there, you'll see my edit form now looks correct. So edit form is basically a component provided by Blazor to allow us to have a form that supports validation using the whole component model mechanism. So you can see here I've got my form. I'm going to turn on the data annotations validator. This component doesn't really display anything. It just wires up the validation. And this will show the validation summary if we have any validation errors. I've got my name and my hex code input fields, and then my validation messages specific to those fields. This bind value is what actually connects the form itself to the underlying object model, which you see right here. All right. Also, too, we have a parameter for the button text, so you can customize the button text being passed in. We also have a callback. So when a parent component wants to talk to a child, it passes data down through parameters. But when a child wants to talk back to the parent, it fires off a callback. So this event callback will basically take the color that was submitted in the form, output it to the parent, and actually then we can add the color to the list using the service. Down here at the bottom, I've got my actual color form data model. This is the actual class that we're using to bind the form above. You'll notice I've applied here these data annotations for basically describing the validation on each field. Notice I did not use the color model from the shared project here. I created a new model specifically for the form. I don't want to be applying these validation attributes to my common model. I really want to just apply them to one that I'm using here specifically with the form itself. Okay, so now that we've got the form in place, our next step is we need to go ahead and wire this up in the page so that we can actually add the collected color data. So I'll come up to here. We'll go back to color tool, and we're going to add a call here to color form. And then we need to implement this add color function. And we'll put that right here. So now what'll happen is it'll take the color data that we've collected, pass it in as a argument, and populate the parameter here. And then we'll add the color, and then boom, update it, and we'll have our new list of colors. So let's go ahead and run that, and let's see what happens. So if I go into color tool here, let's say I don't fill out the form at all. You'll see I get the validation. But if we fill it out, we'll just make up something here real quick. Not a valid hex color. Should be a valid hex color. Hold on one second. Let's double check our validator for that. It's set to 3. That should really be 6. Okay, so let's stop it and start again. All right, so if we try to do 3 and 3, fails. But if we add in a few more characters here to make it 6, now we can add our color there. So you can see there's our color being added to the list. Okay, perfect. So now we have the ability to add colors. The last step we want to do here is set this up so that we can actually remove a color. So to do that, we're going to update our color list component right here. And we're going to replace it with this version right here. Okay, so we're going to add a button here for each list item. And when you click the button, we're going to run whatever function is passed into here. And we're going to output the color that was clicked on. Now you'll notice here, I did not specifically hard code what kind of action is being done here. We're going to use it for delete, but potentially you could pass in any number of different functions depending upon what action you want to perform. And so doing things like making the action button text customizable and not using the word delete to describe this particular parameter allows it to be more reusable, more generic. We kind of did the same thing over here in color form when we set up the button text to actually be customizable. So we could call it add color as opposed to submit. So these are little things you have to think about when you're working with components, because components are inherently reusable. And there will be things you might want to customize about it as you use it each individual time. Well, now that I have the ability to click a button and output a color, now I need to update my code to actually do the removal. So let's save all this and let's come back over to color tool. First thing we'll do is let's put in a function to do the actual removal. So I'll just drop that function right here. And then we need to add in 2 additional parameters to the list so that we can do that delete. So we'll make the button text just be an X, and on the color action, it'll call remove color and then remove the color. So we'll go ahead and run this, and let's take a quick look. We'll go over to color tool, click on the X, and now our color is deleted. So what we have here is we have really a full stack application. We've got our client-side code running as Blazor WebAssembly. We've got our server-side code running as ASP.NET MVC. Please keep in mind, the WebAssembly is running completely independent of the server. All the server is doing is serving up static files like JavaScript files, WebAssembly files, HTML, CSS, whatever, but none of that code executes on the server. It only executes on the client. And once that WebAssembly program is running on the client, the only relationship it has with the server is to make AJAX calls to pull in data using that HTTP client, which is exactly the same thing that a React or an Angular application would do for calling back to the server to get data. So with the Blazor WebAssembly hosting model, your application, the Blazor part runs completely on the client. With the Blazor server model, your UI code is running on the server, but it updates the client over WebSockets in such a way that it doesn't trigger the page reload. So Blazor gives you that single page application experience, whether you're running WebAssembly or server. It's just a question of where do you want to run that UI code. And depending upon the requirements of your project, you would choose one hosting model over another.
Couple of things I want to highlight here real fast before I let you go is first, right now there is no official way of unit testing in Blazor. However, there is a community supported way of testing in Blazor called bunit. Just search for bunit, and you can actually test your actual Blazor components, and it'll walk you through step by step how to configure like an XUnit test or whatever in Visual Studio to use bunit. It works really, really well for testing your components. The next two things I want to mention is people always ask me, well, what about data grids and stuff like that for working with Blazor? I've used two of them, Blazorize. If you're doing non-commercial stuff, you can use it for free. If you're doing commercial stuff, you have to pay. But it's got a lot of different types of components that you can work with in your application. Another one that I've also used with Blazor is this one here. And so if you go to Blazor, you can check out the different components and stuff they have available here. Both of these have worked very well for the things that I've worked on. Now, keep in mind, it is another DLL, of course, being downloaded into the browser. But who wants to code a really sophisticated data grid from scratch? Probably not, right? So there are libraries out there that exist for working with Blazor and getting a lot of those really nice UI components that you might be used to from working with, things like ASP.NET MVC and stuff like that. Okay. All right. So what I'm going to do is go through the questions here real quick, and let's see what we've got, and I'll do my best to answer them. Let's see here. Let's see. Yeah, question about the performance. Yeah, in terms of the initial download, it can be a little bit slower. But like I said, there's enhancements with pre-rendering and stuff like that that are coming about, and it's only going to get faster with time. That being said, I've also seen React applications that were slow on the initial load too. There was a lot of stuff being downloaded unless the developer was doing some type of isomorphic rendering or whatever ahead of time. The React applications can be quite large as well. Let's see. You would not at the moment use Blazor like inside of existing WinForms or WPF or anything like that. There is a talk of a Blazor desktop version. I don't know that much about it, but no, it's a totally separate technology. Let's see here. Vue is another popular, client-side library. Blazor would be an alternative to using that. Let's see here. Any problems with Blazor server? Everyone's moving. People are moving to Blazor WebAssembly because it's like cool, right? But Blazor server is perfectly fine. Both are equally supported hosting models. If you need that Windows authentication, Blazor server is the way to go. For a while, I was Blazor WebAssembly only. But then in terms of working with it and using it, for me, I'm comfortable with either using Blazor server or Blazor WebAssembly. I think you can make arguments for both hosting models. And what really sold me on it was these Razer client libraries where you can put your components in a library and reuse them across two different Blazor hosting models. I mean, that kind of seals the deal for me in terms of working with Blazor, is having that flexibility. Let's see. In terms of ahead of time compilation, because everything is already compiled, that's the issue with things like Angular and ahead of time compilation is because you're going from string-based templating into generating basically view classes. And ahead of time compilation is nothing more than doing that, but Blazor's already compiled. So the question is just how quickly can we get the DLLs there, not necessarily doing more compilation per se. You can host it anywhere you would host a static site. So you could put it up in blob storage, you could put it up on the new static web app on Azure, you could put it up on a CDN. And in the demo, we had it on a REST server where it was just served up as static content, any number of different ways. But you just deploy the files like you would deploy any other file to those static hosting environments. Let's see. Well, if you're deploying it out to IIS, it would just be like deploying out another static piece of content. That's the thing with the Blazor WebAssembly. There's no server part to it. It's just literally static content. And then, of course, it all runs in the browser. So it's just however you deliver static content. Oh, what's the advantage for VS Code for Blazor rather than Visual Studio? I'm on a Mac, so I use VS Code on my Mac to code all of my C# stuff. Let's see here, terrible echo. Sorry about the audio, everybody. I did not see that popping up. I apologize in the question list there. Let's see. Any other? It's all about audio here. Let's see. Is this one WebAssembly? I'm not sure what you mean by the question. WebAssembly is a standard, and .NET has been adapted to run as WebAssembly in a web browser, but there are other languages and platforms you can use. You can write your WebAssembly code in C or C++. You can write it in Rust. You can write it in Golang. I don't know for a fact, but if I had to guess, there's probably a Java version of this out there. It's just Blazor is the .NET solution to doing this WebAssembly stuff. All right. So in my working with Blazor, when I have to make a bug fix while I'm doing development, I have to go through that whole process of stopping and starting. They are working on hot reloading and stuff like that. I think you're going to be seeing that come up in .NET 6, but at least for right now, my experience has been stopping and starting the server to do my debugging back and forth and making fixes to it. Let's see here. On the third-party stuff, Sync Fusion is the one that I've used as well as Blazorize. There are some other ones like Telerik and stuff that you could explore, but those are the two that that I have experience with. So the local file system, everything that runs in WebAssembly runs in a sandbox, just like JavaScript does in the browser. So even though you're running your .NET code can't talk to the file system. In that browser environment, everything is sandboxed. It's as secure as your JavaScript stuff is or anything that runs in a web browser. For saving data on the browser, in terms of working with something like local storage, actually, I'm trying to think, in my Blazor apps, have I tried writing anything to local storage? I'd want to say that you would probably need to wire up some JavaScript code and use the JavaScript interop to be able to talk out to the local storage of the browser and then to be able to retrieve that. There could be an API for it in Blazor. I haven't had a need to look for it yet. Let's see here. Yes, the content from today will be made available to you when they post the video, so you can go back and download all the code and everything from the presentation today. For authentication, essentially you have all the same authentication options that you would have for a React application or any other client-side app. So whatever authentication options are available for that, you can make use of that with Blazor. If you're looking for that Windows authentication, which can only happen if the app runs on the server, then you're going to have to use Blazor Server. In terms of the community, I will say that everything I've had to find answers to concerning Blazor online, I've found answers to. So there seems to be a pretty active community out there in terms of people working with it, writing code, lots of great Microsoft documentation, third-party companies providing components for it, even BUnit, a community-driven project for doing unit testing. I'd say the community is definitely not as large as something like React, but for being at the beginning of what I kind of think of as kind of another, web development revolution, the community is quite strong. So Azure Functions would be the REST API part of it. So the question is, can you use Blazor with Azure Functions? That would be the REST API part of it. If you do like a static web app, which is a new thing on Azure, you can have a static web app which will use your static Blazor, WebAssembly for the client side piece, and then you could call an Azure function through like a REST API to be able to get all of your data, and then the Azure functions are tied into the static web app. So the answer is yes, you can use Azure Functions, but that's just because you can use Azure Functions for any type of REST API backend, regardless of what the client-side technology is. Let's see. Moving from Angularjs. So one of the problems with Angularjs is that in Angularjs, prior to Angularjs 1.5, there was no component API. In Angularjs 1.5 and later, there is a component API. If you use the component API in Angularjs 1.5 and later, then you could start building your Razer components, maybe following the same kind of component tree that you built for that Angularjs app. However, if you used Angularjs 1.4 earlier, you basically just have big monolithic templates, and you're going to have to rethink your UI structure from the ground up in order to do the components. But you'd have to do that if you were going from Angularjs to Angular, or Angularjs to React, or Angularjs to Vue. The same type of transition would have to be done going from Angularjs to Blazor. It has nothing really to do with Blazor. It just has to do with going from working with monolithic templates into UIs that are composed of smaller components. That's why I say the principles and ideas of React, Angular, Vue are really the same as Razer components. In Blazor, it's just you're using C# instead of JavaScript. The apps work on the phones in the sense that a web page loads up. All of this is just web pages. None of this is, none of these are like native apps. So if you're asking, does WebAssembly work on the phone? Yes, it does. WebAssembly works on all modern browsers, on all platforms. It's a standard. All right, let's see here. The final Blazor demo was WebAssembly. Yeah, I only did the 3 other technologies right at the beginning. Once I did that first WebAssembly one, everything after that was all WebAssembly. In terms of accessing protected APIs and stuff on Azure, you would just use whatever libraries or interfaces you're using now. I can't think of anything specifically that wouldn't work with the Blazor WebAssembly. There might be something, but depending upon how you're calling Azure and interacting with various endpoints, it should all be about the same. Let's see. No, the DOM cannot be modified from WebAssembly. That's why the JavaScript piece is there. You'll notice when you look at the content being loaded up in your Blazor application that it does load up some Blazor JavaScript code. That JavaScript code is what facilitates the WebAssembly talking to JavaScript to modify the DOM. So you're not going to be writing like jQuery type applications in your Blazor code. And the reality is you don't write jQuery like applications in your React code either, because React handles the DOM update, and the kind of the similar concept is how Blazor handles the DOM update. So there's really no need to even think about direct DOM manipulation really. It's really you're writing components and you're letting Blazor through its mechanisms update the DOM tree for you. All right, let's see here. Oh, so .NET Core 3 was when Blazor Server and WebAssembly were first available. .NET 5 is just the latest the latest version. .NET 5 and C#9 have some cool new features in them that make coding a little bit easier, I think, but it's basically the same thing. Modern browsers would be Safari, Edge, Chrome, Firefox. Anything that's like an evergreen browser, specifically not modern, would be Internet Explorer. So even the old Edge supported WebAssembly, if my memory is correct. So you have the new Edge and the old Edge. Even the old Edge supported WebAssembly. So, but you know, IE basically is not going to work with this. Let's see. I have not experimented with the mobile Blazor bindings. All right, pre-rendering. So you can do pre-rendering. In fact, pre-rendering is the default for Blazor server. That's one of the reasons why it's kind of super fast when loading that initial page. There is some pre-rendering built into the WASM, and the pre-rendering is going to get even better when you get into .NET 6. CSS. So you can include just regular style sheets if you want. You also can create a Razer component, like a toolheader.razer.css file, and it will basically create CSS isolated to that particular component. And then when you compile it all up, it'll put all that together. All right, cool. That was a lot of questions. And once again, everybody, I apologize for the audio issue there. Hopefully you could understand most of everything that I said throughout through the webinar. Okay, well, that pretty much does it, unless anybody else has any additional questions. I appreciate everybody making the